Right, part 2. According to the data in the lesson, the per person water footprint of the United States was 2,482.7 water foot. We'll make it per cubic meters per year per person. Suppose that the population nation and then we have this other bit of data. Population of the United States was 209 million, and these happen to be people. Estimate the total water footprint of the United States in cubic meters per year. Explain how you arrived at. So we have a number in cubic meters per year, and that number is per person. Because if you remember, this is what we were given in the assignment: cubic meters per amount of water used per year. So if we multiply this by number of people per the country, then we will get, the people will cancel, and we will get the number of meters cubed per year times the number of people. And that will give us that will just give us cubic meters, and that's per country. So we have this 2482.7 meters cubed per year per person times 290 times 10 to the 6, because it's millions people per USA. So the people cancel, and we'd have to do that calculation. So we have 248.2 times 290, and it's, so this answer right now is in millions. 719,983, and we still have this word. This is millions, so this is times 10 to the 6th. So that means add 6 zeros. So we have 719,983,000,000. And so ones, thousand, millions, billions. Calculate total water footprint of the United States. And write your answer in scientific notation. So put the bar there, the decimal place there, 1, 2, 3, 6, 9, 10, 11. So we're dealing with 10 to the 11th. And then we have 7.19983 times 10 to the 11th would be this. Oh, now this part with 2 decimal places. Ooh, they did sneaky 99. So 9 means plus 1. So 1 plus 9 is 10. Add a 1 to 7.2 times 10 to the 11th. That is a question I would write, because I love to make people do the work with the roundup. Molly has to pay 15% on the profit of her craft business in federal taxes. Her revenue is, and her expenses are. So here so this is a 1.7 problems, and we didn't do 1.7 anymore. But just to let you know, profit equals revenue minus expenses. And tax is equal to 15% on the profit. So we need to figure out the profit, which would be this 18,230 minus 5,642. And that would equal a number. Get my calculator out. 18,230. 230 minus 5642. And we get 12,588. And so now we need 15% of 12,588, which is 0.15 times 12,588. And that equals 1,888.2. Oh, well, I guess that was the math. And then that was me calculating. So it's 1,880.2. But when you fill in your taxes, they often want to ignore that. So it's just 1,888. Write 1 to 2 cents explaining how you calculated her taxes. Be sure to use the writing rubric. So we need to find the profit. To do that, subtract expenses from her revenue. Revenue, is it just UE? It is UE. From her revenue, which is money taken in. Then the tax is 15% of her profit, which equals 0.15 times revenue minus expenses. Karina has $1,200 in taxable income. Suppose her tax rate is 11%. Oh, no, I'm not going to, you do not need to know how to do that problem. So I'm just going to ignore it for right now. The following tables shows the number of pets, dogs and cats that some people have. So we have, this would be of a total of 45 dogs, of a total of 190 cats, of 80 young people, let me rewrite that. That was my dyslexia coming in there. 80. And then older people, we have 155 old people. All right, so we have like all our little subtotals. And then we have to interpret the sentence. What's the print of younger people? So that means we want just this bit of data here of younger people who has dogs of a pet. So we need, P% is the number of young people and dogs out of number of young people. So we have 30 out of 80. So that is 30 over 80, which equals 3/8, which is 2.5. I think it's 3.7 or 0.375. 0.375. So that is 37.5%. And then depending on the rounding, if it was 2 nearest whole percent, it'd be 38%. If it was nearest 12%. What percent of cat owners? What percent of cat owners were older people? So now we want this bit of data and those guys, cat owners. So for this one, P% is going to be the number of older people and cats out of the number of cats. So older people and cats is 140 out of total number of cats, which is 190. So 140 out of 190 is 14 over 19. That one I do not know in my head. 14 divided by 19. 0.736, which would be 73.6% or 74%. Depending on, I would then, you'll notice when you take the exam, it'll give you rounding instructions. So, oh, that must have been highlighted when I saved it. Suppose that there are 150 million in your town, and suppose that your town uses 3 times 10 to the 9 cubic meters of water per year. What is the amount of water in per person? So this is per capita. This is volume per capita is volume of water, H2O used, divided by population. So we have this 310 times 10 to the 9th divided by 150. Doom, 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 doop, doop, doop. So we've got two approaches to this. You could go with, well, I have 310 followed by 9 zeros. And I have all over 150 followed by 6 zeros. And cancel at least 6 zeros to 6 zeros and 1 0 to 1 0. And so our problem has been reduced to 3,100. Well, no, 31,000 because it's 1, 2, 3 zeros left over 15. So if I'm estimating, this is roughly 30,000 over 15, which would be 2,000. But we're not estimating. But at least it's good to sort of have an answer to make sure you've plugged it into your calculator right. So I'm now going to go to my calculator and I'll type in 31 followed by 3 zeros and divided by 15. And I get the actual answers. The calculated answer is 2,066.66666. And this is cubic meters, and this is person. And this is cubic meters per year, actually, if we wanted. And so the units here are meters cubed per year per person. Suppose that in your math reasoning section has 23 students and 2 other sections of math reasoning have a total of 44 students. So, you know, you have section 1, section 2, section 3. So this is ours. And then we know that the total here is 44. So what percent of the students are in our section? So we need 23 out of the total. So we need P% is our class number out of all students. So our class is 23 out of, and then we have is 20, I was saying 3, why was I drawing 23 plus 44? So that's 23 out of 67. So to have an estimate, it's always good to have one of those. This is roughly 20 out of 60, which is 1/3. So we're expecting somewhere in the 33%. Right? So it's always, as I said, so the estimating is also good to make sure, like, let you know your calculator's doing it right. So I have 23 divided by 67 times 100, and I get 34.32%. And depending on, this will be round down, so plus 0, so 34% of students in math reasoning are in our section. Given the following information about performance enhancing drugs. So remember, one of the big things here we're looking for is true positive, true negative, false positive, false negative. So let's just think a positive test. So athletes using PEACH should be getting it. So this is a true test result. A positive, if they're not using, then this test here is a false test. And then if they have a negative, if they're using and have a negative test result, this is false. And then if they are not using and they have, this one's true. Granted, I should have checked to see if the questions. One thing they're asking is fill in the missing blanks of the table. So, these are subtotals. So this is 9 plus 5, which is equal to 14. And here we have 5 plus 485, and that is equal to 490. And we can check 10 plus 490 is 500, and 14 plus 486 is also 500. So all of our numbers are true. Think about the situation. An athlete gets a negative result on the test. What is the chance that the athlete is actually using PEDS? So that's a false negative. So we want to know, we are given, so this is asking for the probability of a user given a negative test. So then we only want the negative test results. So we have our negative test. We have user, non-user, so and then total. So we have a total of 486, and users is 1 to 485. So the fact that they're a user given a negative test, that's going to be 1 user out of 486 tests, negative tests. And that, what is the chance? Well, 1 out of 486. They're not actually asking for a percentage. This is about 1 in 500, which is about 2 in 1,000, which is 0.2%, roughly. It's going to be a little less than 0.2%. What percent, and then the last thing is what percent of all tests are incorrect? So that means false. So this is, we need P% of number of false tests out of total number of tests. Total number of tests is 500. Number of false tests, well, that's going to be, what do we have our numbers? We have the 1 plus the 5. So we have 6 out of 500. divide each by 5, we'll get 1.2 out of 100, so 1.2%. And there's all our answers. But you'll see that in the back. Okay.